one as well, like a second very short one. Basically, we're trying to get you primed for working on your project, and so part of that is one of your options for your project is to actually use data from APIs, right? So we've talked a lot about like building a domain, building a model, building a database. But where do we get the data to fill that database? We can't just use Faker all the time, even though I want to. So you can get the data from APIs, and we'll talk about what those are this morning. This afternoon, we will talk about Git and how to have a productive Git workflow with your partner, with your group mates, because you do not all want to be working on the same branch, if you will, and we'll go into detail there. So everything here is in the service of helping you build a cool command line application. And then there aren't hardly any labs that are being deployed. There will be one more there will be a pair programming exercise right after this for you to practice what we're talking about. And then a pair programming exercise tomorrow. You all remember Flatiron BNB? We're going to revisit that now that you all are experts at that. But apart from that, you'll see on the calendar that most of the time this week is just for you to work on your projects. And we'll announce the project pairings. I mean, I can tell you right now what they are, but we'll save it so you all have some suspense. We'll announce the pairings and this afternoon, right after lunch. Yeah, any questions about what we're doing this week or why we're doing what we're doing? Okay, let's dive into it. So this lecture is on APIs, which in the context of what we've done with Ruby is really just like hashes and how they relate to the internet and how we can extract useful information from the internet. So our goals, just real quick, are to do a quick survey of how the internet works. What is the basic model for understanding what is happening when people use the internet? Then we're going to practice using an API, accessing information that's in an API. And we'll talk about what an API is. I'm not going to just keep saying API over and over again because I feel like that's a bit of a buzz term that gets thrown around. And then we'll build a very rudimentary CLI. So with that, let's talk about how the internet works real quick and start. We won't like go into super detail. We'll go into more depth next module when we dip into Rails. But the internet can be seen as basically a bunch of computers talking to one another, right? We're all kind of on the same page about that. Like that is what is happening in the internet. It's just all these different computers talking to one another. What the role that computer plays depends on basically what it's trying to do. So when we classify what is happening on the internet, we divide the computers up into something called the client, and then we have something called the server. And yes, they are just boxes. Both of these things are just computers, right? So generally, when you or I use the internet, the client is your browser on your computer, or the client might be like your phone, right? Making what we call requests of another computer, which, I'm sorry. Man, Monday morning I wrote box instead of writing. You guys have to stop me. I had a long weekend. I would love it if someone would walk in here and just see. Okay, so we've got two computers, a client and a server, right? The client makes requests of the server. So client, you or I go to google.com, bam, we hit enter on our browser, and that makes a request of the server that hosts Google. That is the basic transaction that's happening there. The server, the computer that's over in Googleplex, is taking that request, handling it, thinking about what to do, what to give back, and then returning what we call a response to the client. And this whole beautiful sequence of events is what we call the request-response life cycle. And this is the lifeblood of the internet. This is the dialogue that makes up, the whole World Wide Web is communication between different computers, one of which we call the client, the other we call the server. Clients make requests of servers, and servers return responses. It's pretty broad overview. We'll revisit this again, but basically, we can definitely go into more detail in this, and so let's flesh out really kind of what's going on here. These computers have to talk to each other in a very specific way, and the reason for that is, we all are aware of the fact that computers take very many different forms, right? And they all have different operating systems, they're all running on like different hardware, and things can get pretty crazy. So the way that we make sure that all these computers are able to talk to one another, even though they're not only like geographically in different places, but just what they're composed of is different, is they adhere to something called a protocol, or a set of rules for communication. And we call this the hypertext transfer protocol, which you might know as HTTP. And again, I'm not gonna write that out because we're gonna go over this again when we talk about Rails. So HTTP is the protocol or set of rules for computers to communicate with one another via the internet. And in HTTP, in the hypertext transfer protocol, there are certain ways of communicating, certain types of requests. And we call these the different types of HTTP verbs. So in a request, a client can make different types of requests. And these requests can take the form of, hey, get, or post, or maybe patch, or delete. These different HTTP verbs can also be seen as just different types of requests. And when we look at a request itself, a request is composed of basically, kind of broadly speaking, there's definitely more granularity to this, but a request is composed of like a header, which contains information about the type of request that's being made, so it includes the verb, and then also there's a body here. If the client is sending information to the server, there would be information in what's called the body of the request. So a client can say, hey server, get me something, and the server will respond in kind. The server, on the other hand, can also create a response, and that response is also divvied up into sort of a header body situation, where the header contains a bunch of like metadata, data about the data that's being sent back to the client, and then the body of the response, which is could take really a variety of different forms. So any questions about this? Does this idea seem pretty fungible to you? Does it seem pretty real? Okay.
In the body of the request of the client to the server, that's just like extra data that the server might want about the client.
Yeah, like if you were doing like a GET request, you probably wouldn't have much or anything at all in the body of the request. But if you were posting data, so posting is another way of saying like, hey, sending data to the server and telling it, hey, I want you to like stick this in there. Then you would have stuff in the body. Yeah. Today we're just going to talk about like doing GET requests. And officially speaking, because the guy, well, actually no, I'm not going to tell that story right now. But yeah, so the body is kind of optional here in the request. But the server is always going to return like stuff in the body here to let you know what's going on. So in the responses that the server gives, the server can give different types of responses. So the content of the body can be very different, can take different forms. So I've talked about this really abstractly, but if I go to Google or to Chrome here, and I actually just type in the name of a website like wikipedia.org, and I hit enter on my browser, I am the client. I'm making a GET request of the server that's hosting Wikipedia. I'm saying, hey, get me whatever you've got that's located at wikipedia.org. And it sends something back to me in kind. What does it send back to me? What are we looking at right now? If you dip into your dev tools, you can see exactly what's being sent back to you. And that is basically, this is in the body of the response, this HTML. And there's also stuff that's in the header. So if we can actually look at this. If we go to performance, let's hit record, and we're gonna refresh the page and stop. So you can see all of these different things happening here. So if we zoom, change the scale of this a little bit. How can we do this? No, this is what I want. So here we see, this is the response of the server. So these are all the, oh, here we go. So here is information that was in the response header. So it's all of this like metadata about like how the content is encoded and like the status of the request, whether it was successful or not. Here's all the headers that I, the client, set implicitly, and we don't have to worry about this as the user. Our browser takes care of a lot of this for us. And then the actual body of the request, generally speaking, what we experience is what we see right here. And what's really being sent back to us, though, is just a bunch of text. So all of this HTML right here. Some of which there is some like metadata or data about the data in the HTML document, and then it's all of this like information about the structure of the page. So I, the client, made a get request of the Wikipedia server, and then it sent me a response that had like some metadata about the response, and then also like what we really care about is like what's in the body. And then our browser like looks at it and then renders it for us. So quick basic overview of like what's going on in the internet. And this happens all the time. There are different types of requests. There's different types of responses. But really when you boil it down to it, whether you're talking about like, a laptop computer and a website, or different like sensors and the Internet of Things communicating with other servers, like it's just client server. This is a basic underpinning of everything. So any questions about that? Okay, just to give us some background for what we're going to do. So with that in mind, HTML is not the only like response. I think there's a tendency to think like because most of what we access is just like web pages, that like HTML is the thing that servers get back to. But that's not necessarily true. There are different file formats, like there's HTML, there's XML, and there's something called JSON, which is what we're going to look at, because it's going to look pretty familiar to you. So there is an API, and we'll talk about what this is in a second, that we're going to use. And we're going to look at the Google Books API and actually look at some books. And by default, if you go to the Google Books API, it'll send you back information that looks kind of like this. What does this look like to you all, based on what we've worked with so far?
Hash.
Yeah, it looks like a hash, doesn't it? Right? Or maybe you have experience in Python. Maybe this looks like a dictionary to you. But in the context of what we've done with Ruby, like this is a hash. We even have the curly braces. We've got some key value pairs, right? And this format is known as JavaScript Object Notation, or JSON, which really doesn't just live in JavaScript world. It's a file format that's just kind of grown to encompass this standard hash or dictionary-like format for returning data. So you, Will, that was telling me that MongoDB largely just works in like storing things as hashes. Yeah. And so JSON is probably like, there's a lot of JSON in that world. So this is just what's great about the fact that we've worked with hashes is that it gives us the ability to work with this data type that's really sort of a universal data type. So let's talk about real quick, what are APIs, right? Like what is this term that people like to throw around and try to get seed funding for and stuff like that? An API just stands for something called an application programming interface. And that is what it is at a very general level. When you see the word API, you could just think of like software interface. bam, done, like full stop. And then you could start thinking about maybe what type of API it is. But the APIs exist at a ton of different levels. Microsoft Windows 10 has an API so that you can run like old Windows software on it. So it's like creates an interface between like the Windows 10 kernel and like all this like legacy code that it lugs around with it so that people don't get mad at Microsoft, you know. APIs exist, for instance, between like software and hardware. So there's like libraries that you can get for Python that allow you to, or libraries that you can get that are written in Python for like Raspberry Pi that allow you to easily program hardware in Python, but it really is acting as like an interface to like the C level code that is then like driving the hardware. But what we generally are seeing in terms of APIs, or what's really popular, kind of sexy in the world of APIs, is like web APIs. And so a web API is generally referred to as like a RESTful API. And this is, again, something that we're going to cover next month. It's just a little taste. A RESTful API refers to this structure of an API that's RESTful means representational state transfer, which means that depending on the type of request that the client makes, so the type of, are we getting, are we posting, are we patching, are we deleting, and where they make that request to. So in your browser, you have like, you can split up a URL into like a domain section and then into like a resource path section. So for instance, if we go back to our Google APIs thing. So if we go back to like www.googleapis.com, conveniently enough, this is the domain, right? This is like where the server is. But then everything that's after that, so books / volume1 / I'm not going to write all of that. That is actually the resource path. So that's like in the form that is like legible to the typer, like what the user wants to get, or what the path is to the resource on the server. And in RESTful APIs, we create a website. We create like a web server that is keenly sensitive to the type of request that's being made and the resource path that's being given to it. And the data that you get, or the way that in which you manipulate the data, is directly tied to the type of request and like the resource path that you make. So that's what's meant by RESTful. It's a very like strict way of like organizing and aligning the types of requests with the resource path to alter or read data that's on the website. And it's hard to think about this without like seeing an example of it. So, but for instance, if I say get and my resource path is /books, that means I should, as a client, I should be getting a response that reads me like, right? Let's think about this in the context of CRUD. So get would correspond to reading, right? Post would correspond to creating. Patching would correspond to updating. And deleting would respond to delete. Yeah, all right, yeah, awesome. So if I get /books, I should be able to read, like get that books data back from the server. If I'm posting to books, then I should be actually inserting new entries into the database of the server, and specifically the table that corresponds to books. If I'm patching, I should be updating. If I'm deleting, I should be deleting. And then I can get very specific in terms of my resource path. So if I do v1 / volumes, that means I'm going to be like searching for books based on volumes. And then there's this question mark q equals. These are the parameters of the path. So specifically, this is confusing. So let me put in something else, like, I don't know, beans. So now the Google API will return for me any volumes that have to do with beans. For instance, who can forget Beans, A History by Ken Albala? So, you know, this is a RESTful API because I'm making a GET request to book/volume, so I should be reading books volumes, and then I can also type in parameters here specifically to winnow that down a little bit. So any questions about that, like what a RESTful API is? We're going to build one ourselves. It's not too crazy. Next mod. Okay, so what does this all have to do with us? I'll explain in a moment. So an API, just to take a step back real quick from that detail, is that an API really allows some service to give like up-to-date access to information, and like just the information, not have to go through like all the cruft of like clicking through a website and stuff like that. And it kind of adheres to this principle of building software that is Lego-like, that building software that you can kind of connect to other software and build other cool things with. So APIs usually don't exist to just be there on their own. RESTful APIs and any API exists to connect different things together. So connect the huge database of Google Books with the world, right? That's what the Google Books API is. It's an interface to the Google Books database server. There's a little bit of a difference here. So some of you might be used to scraping, right? Or like scraping the web and going through and like harvesting the HTML from a web page. I can show you how to do that if you're interested. That's like really dirty, right? You're like going to a website that's not designed to like give you just the straight, clean information. You're taking all the HTML and trying to parse it for information. Scraping is like getting a bunch of like ore out of the earth that's not refined and then having to do all this work to like get it out. And the API just gives you like the straight juice, just gives you the ingots, the refined product that you wanted in the first place.
Does the API have the same problem with scraping, that if the web page updates, then your code doesn't really work?
No. So that's not a problem because the API, a RESTful API, is standardized. Yeah. Mm-hmm. So that's what's great. It's that you almost never run into that problem. So what we're going to do then is kind of what does this have to do with us and like mod 1, week 3, is we're going to start out by just making requests to an API in our projects and then parsing what we get back and using what we get back to populate our database and create like a really cool application. Some examples of what students did last time was one of them made like a climbing routes app, so they found like a climbing routes API. So you could go into the command line and type like where you were, what difficulty rating you wanted, and then it would make the request accordingly, or not make the request, but it would go into the database and find those things. But they populated their database using information from the API. Another group like made like a beer app, and so you could find a brewery app, so you could find like different breweries in the area based on like the phone number you put in or what you're interested in, stuff like that. And all of that information was stuff that they harvested from an API. So how do you like figure out how to use this stuff? There's a lot of great resources. Like one good one is actually on GitHub. It's like free, free APIs or something like that. Free public APIs. So this is an ongoing like updated list of APIs which specifically are like web, like RESTful APIs. So you can find APIs that give you like daily cat facts. You can find APIs that give you forex currency market data. Like whatever you're into, you will find generally like an API to a database for that. Yeah, so Ticketmaster, stuff like that. So there's a lot of potential here, and you could use this as inspiration for your projects. Any questions about this? Generally speaking, when you want to go to use an API, like if you, for instance, wanted to build like the next greatest esports web platform, there's documentation on how to use API. So here we are, REST API. Sound familiar? So we could say getting started, and then it tells you basically the structure of the data, and then they tell you whether you have to like authenticate, like provide authentication or not. Sometimes you have to register for these APIs. Not everything is free. And then they give you information on like the parameters that you need to fill in and stuff like that. So let's look at it in the context of the Google Books API, because that's what we're actually going to use. So if we go to the Google Books API, oh, this is fun. So we go to guides, and here's our whole overview. So there's a lot of generally good documentation for APIs, and all it takes is a little bit of patience in reading to figure out how to use it. So if we go to getting started, okay, we need a Google account, getting familiar with books, books concepts. This is cool. Let's keep going. So it tells you whether you need to authenticate or not. We aren't using the authenticated version. Let me see. Here we are. Performing a search. So you could search Google API books without like having any sort of account or authentication. So here it gives us kind of an example. So here we are, HTTP GET request to this URL gives us volumes related to the search terms that appear here. And then you can also identify, like you can use special keywords, for instance, to select things even more. So I would suggest that when you go to use an API that you actually read the documentation for it. And then this also goes into basically what the response is. So if this is a 200 OK, like valid server status response, then this gives you an example of basically the form of the data that you should be getting back. Yeah, so any questions about this so far? It's all pretty cool, I think. Like the whole world is kind of opening to you when you can start plugging into these things. So let's talk about what this looks like in terms of Ruby. So we're gonna just start out building in CLI. We're not gonna go too crazy. I'm not gonna build out the whole thing in front of you, but I just want to show you what you can do in Ruby and how easy this is. So we're going to use gem, of course, because we're not going to write from scratch in Ruby, like, hey, like how to actually make a request of another server. We're just going to use something that will do that for us. So we'll use the REST client gem. So I'm going to go ahead and actually require that.
Is that for all APIs or for the Google API?
The REST client gem can be used with any RESTful API. Yeah. You can always look at the docs for this. I'm going to kind of skip over modeling, looking at the docs and stuff, because I think you all kind of get the message a little bit as far as that's concerned. We're going to require JSON as well. JSON is a gem that helps us parse a JSON response. And then we're also, of course, going to require pry. So let's just try to use this. Maybe I've never used REST client before, so let's just go in real quick, REST client, Ruby gem, and pop into GitHub and just see what we need to do here. And generally, they give you some examples. So usage, REST require it, REST client get URL and optional headers. Great. So I could just like get a URL and be done. So why don't we try that and see if it works for us? So I'll go back. I'll do REST client get. And I'll store this, I'll just restore this as a response, okay? But instead of going to example resource, because I doubt that's very useful, let's go ahead and put this here. We could get a different, I don't know, different search term. Anyone interested in anything right now? Algorithms. Awesome, yes. So here's our response. Let's throw a binding.pry in here. And let's see what we could do. Yeah, I'm so creative with what I put. So we're going to run this dude, Ruby run. That's not it because it's called Ruby app. Of course, you can name your files whatever you want. There will be a suggested file structure, though, for your project. So let's see what the response is. Oh, great. So we get this thing, which is a REST client response object. That's cool. What do we do here? So we can also look at, let's see what the methods are first. Got all kinds of good stuff here. I see body. So remember that a response has a body. So let's just take a chance on this maybe and see if this thing is smart enough to just give us the body of the response, right? Oh yeah, here we go. Now we're talking. So what data type is this that it's given this back to us? And what is this thing? Is it
It's like a hash.
Yeah, look, but always start at the outside. It's a giant ass string. Yeah, so this is not fun. Like, I don't want to deal with this string, right? This is terrible. There's all these new lines in it, and yeah, and the hash is in there somewhere, but right now Ruby's looking at it as a string. So this is why we have another gem called JSON. Let's see, how do we deal with this? I think what we can do, if I remember correctly, is we take the JSON object and we can just parse, or the JSON class, we call the parse method on it, and then we can chunk in the response. And this is what we get by requiring the JSON gem. If we do this, then we're returned our hash. So now we're cooking with gas. Now we've got something that we can work with. So with this in mind, let's go ahead and change our code. So we're going to have our response there, and then we can call our books hash. We can do JSON.parse response. And I encourage you all to look at the docs for these gems to, just so you know what your options are. You don't. I'm just showing you a really basic example. So now we have a books hash, right? This is cool. Let's look at this a little bit more closely, because this is really only the beginning, right? You all maybe started thinking that you were out of the woods because you had already done all of those hash labs, and so you'd never have to use hashes again. But that's not true. Hashes never go away. Hashes and arrays will dog you till the end of time. So we need to figure out basically how do we get to the information that we really want in this hash, right? Because this is a pretty robust hash, right? Like, here's the beginning of it, and then here's, key value, key value, key. The value of this key is an array of hashes in which there are other key value pairs, and then there's also more arrays, and so this whole thing just has kind of exploded on us. But that's okay, because you all are pros, right? So what I would like you to think about is how could we get to our actual book information? Like, where is our actual book information in here? So talk to someone sitting near you. Like, how do we get to, I just want title, author, and description of my book. Where is that in here? How would I get to it?
You would just try it out and hash it around. Figure out where like a gem that just keys. That's all that
Okay, so what are some of your thoughts here? Like, how can we get down into where the books are? How do I get to my books, the title and authors and description? Any thoughts on this guy? Wonder if I can, yeah. Where would I start with this? What do you think, Arya?
Items in brackets.
Items in brackets?
Would it be a semicolon before items?
Great question. What is this key here? What does this look like to you? A symbol or a string? Yeah. So good, but it's good I'm glad you're paying attention to that. Snaps for Arya for getting us warmed up. Awesome. Okay, so let's go there. Items. Awesome. Cool. So now we're down at this level. Okay, and what are we looking at here? This is an array, and not just any kind of array, right? This is an array of what?
Hashes.
This is an array of hashes. So we're not out of the woods quite yet. But if we wanted to take this array of hashes and kind of extract out of it maybe.
Volume info.
Okay, so volume info is where all of our, Danny, is that where you're saying all of our kind of good book information is?
Yeah.
Okay, cool, yeah, because I don't really need whatever that is or that. I just want what's in volume info. Cool. So why don't we try this? We're going to map it because we want to get an array back that's the same length, is referring to the same items, but just kind of with the particular part of what we're looking at instead of everything. So how do I get to volume info? Oops. So I'm going to map for each item. I'm going to grab item, you said volume info?
Yeah.
All right, let's see what this gives us. Okay, a little warmer, and in my infinite wisdom, I didn't save it as a variable. So let's just call this books info. Okay, so now I've got this, right? So a little warmer, right? So now this is what you would do probably the first time you use an API and get this thing back, is you're just kind of picking your way through, okay? How do I get to everything? If I just wanted to grab, well, so we now know that this gives us an array of hashes, right? And in each hash there is info about the title, the authors, and it even includes a description here as well. So we should be feeling pretty good. So let's see now if we could extract just those three bits of information out of this in our code. So now that I know that in order to kind of process the books hash, I need to map, right? And I need to specifically look at the value of the items key, and I need to, for each item, return item dot, or not item dot, but item volume info. This is what we did down here, right? Okay, cool. And I can save this as books volume info for now. Again, we're just kind of sketching this out. Now I want to get out of that another array of hashes, but just with just the core bit of information, not like all of the other stuff, right? So how could I convert this further? How could I take my array of hashes that have all of this information and get back an array of hashes of just like a few things, a few key value pairs? Almost, but dot select is going to filter like the whole hash, right? If we just want to take like one array and then just kind of transform it into another array, what method do we generally use for that? We were going to map, right? So let's grab books volume info and let's map it. This might not be a one-liner though, like we're used to. So let's we can still map do. Let's see if we can basically kind of grab what we want here. So how do we grab, for instance, the title of the book? What would that be if we're looking at a single book?
Book title.
Yeah, just be book title. So book title should give us back the title of the book. Author is probably going to be something similar. Oh, doesn't look like we're so lucky. It's authors. That's fine.
What if it has one author?
We'll see. We'll kind of look at different books and see what it returns instead. But generally, if it's a good API, it's just going to return an array of a single element, so as to not throw everything off. And then if we want the description, it's probably going to look pretty similar, right? Our description.
Do you want authors in?
Yes, thank you.
Okay.
So now that I've done this. Let's just call this books selected info or something like that. And then look at what we're dealing with now. Okay, so if we look at books, selected info, oh, interesting. So what did we miss here? Why are we getting just, well, first off, what are we looking at? What part of the book is this?
Description.
Description, right? Okay. Why are we just getting an array of descriptions? Yeah, because of the implicit return, right? So map is going to return an array of elements, and those elements are going to be composed of whatever is returned at the end of your block, essentially. So we need to return, what type of thing do we want to return? What do we want an array of?
Book selected info.
Well, we want an array of just the data type. Do we want an array of strings or integers or hashes or an array of arrays? Like what were we
Probably
strings or hashes.
We're looking for, well, we still want to be able to like ask for title, author, and like description, so a hash would be a good form for that. So we actually want to return a hash as the last item in this block. And so this is going to look maybe a little weird, but we're going to have a key value pair of title with the local variable title. Authors is a key with the local variable authors, and description is a key. As soon as I put that semicolon there, this becomes a key, and it's also, this is a symbol, not a string. Another way of writing this, if you'll remember, is to put the semicolon over there and write the arrow, but I hate doing all of the shift finger movement, so I just like putting straight up colon there. That jives with me. So now that we've fixed that, let's go ahead and run this one more time. Okay, and if we do, let's bring this up top, books, selected info. Oh yeah, look at this. So we've come a long way, right? From we had a string representing our hash to now we have an array of hashes, and each hash just has a tidy amount of information that we want to use. Title, authors, description. So this is cool, right? Algorithms, this is awesome, but now we're kind of limited, right? Because we have this cool thing that returns this hash of algorithms. Oh, and also here we go, Danny, to your point, if we get one author, we're returned an array of just one element. But now what do we do with this, right? Well, we can do anything we want, right? This hash is kind of a container for our data. So one thing, though, we're creating a CLI, a command line interface, or command line application. So we want some degree of like interactivity, right? We don't want just this thing to be like, oh, here's a bunch of books on algorithms, like have fun, see ya. So what could we use in order to maybe get some user input?
Yeah.
What?
He said
Gets chomp. Megan, you agree? Okay, snaps. Everybody's got the lights on this morning, so let's try it so we can get user input. And this is a very rough program, right? Like this is not what our final product should look like, but you can kind of sketch things out as you go along. So let's sketch.chomp, getting rid of that extra white space. But how will the user know really like what we're asking them for? We should probably give them a prompt, right? So we could give them, I don't know, we could give them like a little prompt. Maybe we could like do something really cool, maybe some art there. Yeah, that looks fun. So, so you can be a little bit creative with your application. It doesn't have to be just please input a book query term. So we're gonna put that, and then maybe we can put like enter a title or some keywords for books in which you're interested. So that's cool, and then we can get that user input, and then do something with it. Now, how would we use this user input, right? This REST client get takes an argument of a string, which represents the URL. So how would we stick the user input into this string? I know you all got stuck on this with the SQL labs a little bit. Yeah, what do we call that? It's a fancy term. Well, yeah, in another world, it's a template literal. I think in JavaScript, right? In Ruby, we call it string interpolation. Yeah, tomato, tomato. So let's stick that guy in there. Why don't we? So we can do user input. Oh, this looks, we should stop and think about like why this syntax highlighting isn't changing. What's wrong here?
Single quote.
Yeah, snaps for Don. Don to the rescue one more time. So yeah, so these are single quotes. So we'll put double quotes here. You might be asking like, why would we ever use single quotes? And that's a good question. Some people argue that it's valuable information to show people that that's the string and that no interpolation is expected. I don't know. I don't think it's that big of a deal.
Oh,
So
double quotes are for interpolation.
yeah, well, you can only interpolate with double quotes and with as the here doc format of the string. So let's pop back in. We are building a command line application. This is becoming cooler by the second. So here we go. Wow, look at that awesome interface. What are these graphics? We're like in the 80s or something. So what are we looking for? Joseph, what do you want to read about? Dogs. Awesome, dogs, and then bam, we pop into Pride because we still haven't like learned how to output what we're getting. But let's look at our books selected info. Oh my goodness, underwater dogs. I got 2 dogs. I got Dogs, Straw Dogs. Who can forget Dogs by Kate Petty, and The Year of the Dogs, and Dogs by Charles Castle, Cancer in Dogs and Cats. Oh, okay. So anyway, so we got all kinds of good books on dogs. Awesome. Okay, so this is cool, right? I mean, I don't know. I think it's cool. I have fun with it. So now let's kind of figure out the last step besides like refactoring this with actual methods. I'll leave that to you since I don't want to take more than an hour. But we do want to return stuff to the user, right? We want the user to be able to actually see what they've input. And we have an array, right? We have an array of stuff. So what would be a good method to use with this array to like print a bunch of stuff out for each element of the array? Your thoughts? If I just wanted to write a method to kind of, hey, for each enumerable of this array of hashes, like spit some stuff out to the terminal. Thank you, Don, for picking up what I'm putting down. So yeah, so let's each it. So because we're not looking to return anything, we're just looking to like send stuff out to the terminal. So .each, I know we're like, don't use .each all the time, but .each has its purpose. It's just its purpose isn't necessarily to like process arrays very effectively. It's good though if you want to do something for each element of the array.
Where do you have this books variable?
Where?
Okay.
Books, yeah, each do, Danny's on top of me, that's good. So each do book, and then we want to put some stuff out, right? But I want to make this really pretty. I want to make this look nice because I'm a vain person. So if I go and maybe I can do something cool, I don't know. I'm going to define this local variable here. I'm going to put it over here. I'm going to call this my octothorpe wall. So one cool thing that you can do in Ruby is you can take a string and multiply it, and what that will do is it will repeat that character that many times. So I'm creating a wall of hashtags.
Can you do that in Python also, or just Ruby?
You can do it in JavaScript, I think. I don't know. It's been a while since I've done Python. I haven't really written any Python since I started working here, so I'm starting to fade a little bit, but I would guess that you could do it. Yeah, my gut tells me yes, but so then let's do this. Let's for each of these. One cool thing, you can store a string, right? And this is useful, so you don't have to like repeat like the same. You don't have to rewrite like 80 characters or something like that. And then I want to maybe put a little space, and then let's put like I don't know, book.title. Wouldn't that be? Oop, not book. I'm sorry, I've been doing too much JavaScript. Got to keep everything straight. So book title by book. Oh my goodness. Wait a second. Here we go. Mondays. Am I right? Do book authors. And then maybe we could do something else cool. Here's another cool thing that I'll do. I should probably store this as a local variable, like star wall thing. I'll call that what that is. So let's put star wall thing there, and then let's put the book description, and puts another space, and then end it. And just for good measure, let's put another octothorpe wall and close it all out. Okay, cool. So let's try to run this. Let's see what happens. So we're going to exit out. Let's run this one more time. Will, what's kind of piquing your interest this morning in the world of literature?
How about action?
Action. Oh, yeah. Check this out. Action, the Sage Handbook of Action Research by, oh, looks like we're literally printing an array here. Well, we can deal with that in post-production, but this is also a huge description. We might also maybe want to like chop it off at some point. Where the Action Is by Paul Durish. And also this guy, but he didn't write a description. Sociology in Action, real nail-biter. Science in Action, Language is Symbolic Action, When Affirmative Action Was White, Rhetorical Criticism. Wow, this is not the books that I thought would come up when we type the word action. But so here's like super primitive CLI right here. So we've gone from knocking on the door of a web server saying, hey, get me some data, get me some books based on this search query, and we learned that by just finding an API that we wanted to use and then just reading how to use it. We grabbed a couple of gems to help us along the way, specifically the REST client gem and the JSON gem, which you all will use if you're going to use an API to populate your database. And then we did some creative string putsing to make this thing look cool, to make the user know what it was that they were getting into and what was being asked of them. And then once we actually got our data from the API, then we spent some elbow grease actually processing that data into a format that was useful for us, and then returning it to a user. There's kind of just a second, Arya, there's kind of a giant step in here, which is like, for your project will be like populate the database with API data. It's like create instances. What I would do is probably create instances of books and authors and so forth in my database here, but we would be here for another hour maybe talking about that. I trust you all can figure that out.
You don't have a database here.
We don't. Yeah, we just have this lousy single Ruby file. Yeah, so another big step we would want to do is like refactor this into different methods. Like, this could be like display intro. This could be get user input. Fetch data that takes in an argument of user input. Process, hash, return book info, stuff like that. Your method should be in the neighborhood of like 5 lines, and if you find yourself writing big blocks of code, you should stop and ask yourself, like, is there a way I can break this up a little bit? Sorry, Arya, what's your question?
It was just, what method would you use to cut down the description length?
Well, a description is a string, right? So a lot of the methods that you can use with arrays, you can use with strings as well. So you could slice it. You might be able to use square brackets and just specify the range of indexes for which you want the actual description. So we could try that real quick. Let's throw, and this is like when you're asking yourself questions like that, just throw in a pry and play around. So if we ran this guy one more time with feeling, well, what are you interested in? WordPress, cool. All right, so now if we look at our book selected info, let's grab like the first one. Oh, nice. Let's grab the, there we go. Okay, so we'll grab this book, right? And let's grab the, specifically the description of that book. What can we do to attack this guy? So you could try slicing, and I believe the first, if you just type in one argument, it'll just grab a single character that's at that index. If you type 2 arguments, that is the beginning and ending index that you're slicing over. So we could say, we can make this Twitter, like you can only grab 140, I guess technically, 140 characters worth of things, right? And then go from there. But yeah, you could manipulate it. So all of your old methods that you're using for hashes and strings and so forth are going to come back.
You would want to probably make another thing, like a condition that if the description is nil, it won't put it out.
Yeah, and or it would put out something like no description. You know, if nil, then like description is no description. Yeah, totally. Another thing to consider is like this method just kind of lops off the, oops. This method just kind of lops off the things at the character. Like see there, it's like, we're done. So one thing to consider is you could always, after that, like, you could always break up this string into like words and then just select like the first 50 words and then like stick on like an ellipsis after that or something. There's all kinds of fun manipulation that you can do here depending on what you want to do. Yeah. Any questions about what we've done here? So this is kind of,
Up to date on these APIs.
well, if they're still live, they're like up like today is how up to date they are.
Can you use a live API the same way you use a RESTful API?
Yeah. Yeah, it's very similar. When you say live API, do you mean an API that is?
Like constantly being updated?
Yeah, being live and being RESTful are not mutually exclusive. Yeah. Because what determines whether that data is up to date is just what is going on in the database end of things. RESTful just is that it describes how you access that data and how that data is made accessible to you. Yeah. Okay, well that is hashes and the internet. This is one more tool in your toolkit for building a really cool project. You are going to practice this in the pair programming when you go back to Tori. And then in the afternoon, right after lunch, we'll announce the project pairings or groups. And let's see here. And just to kind of give you an overview, we'll give you like an hour and a half to think about ideas with your group, and that means like coming up with user stories, coming up with your domain model, and these will be detailed. Either we'll send you stuff out in Slack messages or it'll be in the description of the project itself. We're going to take 30 minutes to talk about Git and what a good Git workflow would be for your small group. And then you'll have another hour to kind of think of ideas and like plan out your project. And then we'll spend, after 4, we'll start asking you all to pitch your projects to Tori and myself so that we can, like, okay, you've got a good idea here, like you should just go for it, divvy up the work. Or there's some things that you haven't quite fleshed out. How are you going to do X, Y, Z? Yeah, and then it's just a lot of project time. So we can start building stuff. Okay, cool. Well, snaps for you guys, and we'll see you in there. If you have any questions, just let me know.